Okay, chapter 6, we're getting into technology, topologies, and Ethernet standards. We're going to get into some pretty simple things here, things that you need to know. But the first thing is the types of topologies that are the major topologies that are out there. Now, the topology is not a specific it's not a specific device type, it's not a connectivity method, and it's not even the logical addressing scheme. It's just how it's physically laid out. And what we're going to get into is a bus topology, we're going to get into a ring, a star, and a hybrid. And a hybrid is just a mixture of those. Okay, so starting off with a bus topology. Now, a bus topology is a very simplistic topology where you have basically a long line of one line of network cable that all the computers are connected to, and there's like a little T connector to each computer. So each computer kind of acts as a repeater in a way, and what it does is it broadcasts a signal out, so that as the traffic continues, if it's not meant for that computer will just ignore it. Okay. Now, the problem with there's no intervening devices. It's all just computers that are attached to the network. Okay. One long line of computers. On each end, there has to be a terminator. Okay. So that's just the capital T. And a terminator is a 50 ohms resistance. Basically, what that resistance does is it prevents what's called a signal bounce. The way I explain it the most is, the best way that I can remember is, think about two people standing across from each other on like two sides of a cavern. And one person says, hello, 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 hello. And the other person says, hi, 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 hi. The problem with a signal bounce is, if there's no terminators on the end of each computer, or on the end of each row, is that it never dies down. So it stays the same. Hello, 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 hello. Hi, 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 hi. Pretty soon, data's going to get lost, because you're not going to understand by the third or fourth line that people scream across the cavern. If the signal strength never ends, pretty soon you won't be able to understand what the other person's saying. Well, that's what's happening in a bus topology. So you have to have that 50 ohms terminator at the end. It's a resistor that terminates, a 50 ohms resisting terminator that basically buffers that signal so it doesn't keep going back and forth forever and just keep getting louder. The medium type, and here's some definitions I want to go over. Media is how data is transferred. So sometimes your media might be a DVD, a CD-ROM. In the networking field, we're talking about the cabling media. Okay, so that could be, coax cable, which is the same as your cable TV. Could be Cat5, could be fiber, or wireless. There's a bunch of different ways that you can connect. Other things is nodes. Nodes is any type of device that connects to a network. So that could be your phone, it could be a printer, it could be a computer, a scanner, whatever, anything that connects to a printer or to a network. Scalability is the ability to grow. Okay, so like you start off in a small business and you have like 3 computers, then all of a sudden, how scalable is it? Can it become 500? Can it become 1,000? Can it become, and some of the issues that we'll talk about in some of these types of topologies is that they're not scalable. The next one is fault tolerance. Fault tolerance is where you have an error on your network, and the fault tolerance is how many errors can happen before the network goes down. So like if you have a high fault tolerance, that means you can have a lot of errors on your network or down computers before there's an issue with your network itself. A low fault tolerance means If there's a little problem, the whole network goes down. An example of that is in a bus topology. If one computer network card starts to go bad, the whole network goes down. So everybody loses. No one has communication with the network anymore. The signal bounce, I explained already. A repeater is basically it regenerates the data transmission. So remember, as we're talking digital. So those zeros and ones, they're regenerated. So it goes. So what comes in here gets recreated and goes back out. So it's regenerated. So let's get started on talking about the different topologies. As I already started, the bus topology here, it's that single coax cable. So basically, the node, the computer, listens for data transmissions, and it sends the stuff out. If you look at this example here on the screen, you'll see that it is an example of a bus topology. Some advantages of these bus topologies is it's pretty cheap. It's a pretty cheap setup to do because you don't have a lot of cabling. It's just one big cable. Some of the disadvantages is that it doesn't scale very well, and it's very difficult to troubleshoot. So the fault tolerance is very low. We had a situation when I worked at the University of Toledo where we were on a bus topology, and we were looking at 250 computers, roughly, segregated into different classrooms and stuff. Didn't know where the error was, so basically what we had to do was we had two computers. We terminated it here and tested it. It worked fine. Then went here, tested it, and fine, and kept moving that terminator all the way through all the computers to find out where the actual network problem was, and that was a very time-consuming problem as opposed to the type of topology that we use here in the NCT room, which is a little bit easier to troubleshoot. The next one, if you look on the screen, you'll see that it's a ring topology. And a ring topology, back to this bus topology real quick. This bus topology, it looks like it's just one row, but when I was at the University of Toledo, we didn't have all the rows of one big computer. I mean, the cable turned and twisted, so we had a lab that was something like this, and computers on these desks. Here is your walkway. Computers on these desks over here. So mentally it seems like it has to be a straight row, but the cable would connect, if that makes sense, to connect all the computers. Okay. Now on a ring topology, the ring topology shows that everything is in a concentric circle. Okay, and all the computers are a repeater. They're in here, and so they're connected to this line. All these nodes or computers. Okay, and what they're doing is that the data transfers in a circular motion, clockwise, one direction or unidirectional. So that means it's only going clockwise. Clockwise means it goes the same as a clock. Counterclockwise means it's going the opposite of a clock. So the data, if this computer A wants to talk to B here, it has to go through all these computers before it gets there. Okay. Now the median for this one can be twisted pair or fiber optic cabling. Some of the drawbacks of this is if you have, again, a malfunctioning network card or computer node, it can disable the whole network. So that doesn't work very well. Some of the benefits, or another thing, is it's not very flexible, and so that means that the growth for this network doesn't doesn't do very well. And again, a single point of failure can cause the whole network to go down. Some of the things that are funny about, the type of networks is if this computer breaks and you take it to the shop, or even on a bus topology, you remove a computer. If you don't terminate it properly, if you don't connect them, take this off and connect these together, what ends up happening is the whole network goes down again. So you could be troubleshooting something that another tech was just working on a computer and removed it from the person's desk, and if you didn't know where in your enterprise that was, it could be a very time-consuming process trying to find it. Now, the star topology is what we have in our class. Now, the star topology has, and that's what basically the majority is. Now, we don't, a true star, a true bus, a true ring topology, they're out there, but typically we hybrid, we mix a little bit. So we have a star wired ring, or we mix match, and you'll see some things in the reading and stuff. But a star topology has a central device. Okay, that central device can be a hub, it can be a switch, and everything connects to that, very similar to what we have in our room. So, we have our main switch here that our server connects to, and then we have a line that goes from that switch to all the switches in each desk. So we have, let's say 4 desks here. And that goes out to all the different computers. Okay. Now, in a star topology, a true star topology, you've got your central hub, and let's say these were all computers. If you have an error, it's got a very high fault tolerance, which means that there is a lot of errors that can take place before this goes down. If this computer dies, every other computer is still running, unless that computer is offering some type of service, like it's sharing a hard drive, or a folder on your hard drive. You'll lose that, but for the networks overall, it's still fine. There's nothing's going to take place there. It's got a very high fault tolerance. It's very flexible. The negatives is that you're running cable everywhere. Instead of one cable, we have a cable, going in here. We have a cable to all the computers, and if you run any redundancy to that, a line going back, that all is costly. You're running more cable. But the benefit of that cost is you have a high fault tolerance. You want to always, one of the things that I always stress in class is that you want production to take place. As a network administrator, as a as a computer technician, as whatever job role you'll be in, the object is that when people show up to work, they can work. And you don't want your network to be a reason for people to be unproductive. I mean, when it's time to work, it's time to work. When it's time to play, it's time to play. And people rely on their technicians to make sure that computers are not causing the issue with that. Okay. Like I said, the star is the most popular and fundamental layout. But you also have hybrids, and we'll just go over a couple of these here. I'm going to show you some pictures on the screen here. We have a star wired ring here. Now you'll notice that this looks very much like a star topology. It is, but this is also logically following a ring topology. You'll see that the yellow lines is the ring part where the information is traveling, and you see the black lines, which are actually the physical cabling. Okay. You also have a star wired bus. Here's an example of a star wired bus. So the logical topology, now here's one of the words that I used before was logical, like logical addressing, logical topology. That's the way data is actually transmitted around your network. It does not necessarily match the physical topology of your network, but it follows that methodology. So like we can have a star ring topology, yes, it's set up as a star topology, but if the data is just going clockwise, then you're following the ring topology, and logically that's what was be taking place. One of the words that you might hear a lot is the backbone of your network. Now, the backbone of your network is how all the cabling and the connections to all the hubs and the switches and the routers and your enterprise, your business, are that's the backbone. Everything that connects to all your little sub networks. A lot of times people use, in bigger businesses, they use fiber because of the throughput that the fiber can handle, how much faster it can be. Fiber optics very expensive. That's why you don't have fiber running to each desk in a classroom, because it's just way too costly for that. So what you do is you have fiber running to different parts of the building. We also use fiber to get farther distances, because you can only get 100 meters out of a Cat5 cable. So you need something that's going to be able to go farther distances, like from one end of a school to the other end of the school would be too far. So you got to figure out how to get data from one place to another. I've used the word enterprise multiple times. Enterprise means the business. So if I say enterprise wide, that means building wide, as opposed to department wide or network wide or subnet wide or whatever. Now here's some other sketches that I'll put up on the screen here. The serial backbone, it's the simplest backbone. It's just two or more devices connected using one single median. So you could go from your router to a switch to another switch to another switch, and it follows a serial layout. Serial connections, they're limiting the distance, the span between each one, and they're not used in modern networks. You have a distributed backbone that is able to connect devices. An example that you have on your screen is very complex. You'll notice that you've got your router in the center. You have 3 tiers of switches, and then underneath that you have even more, and it's distributing the work of that. Now the potential for this is a single point of failure. So like if your router goes down, then there's a lot of network connectivity that can take place, but you've kind of lost everything else. Whereas if you're a switch connecting 2 other switches, then everything in between connects. That's why another word I've used repeatedly throughout this podcast is redundancy. Redundancy is when you have 2 devices or whatever doing the same job. We build in redundancy into our network, so if there's a problem, like a network failure, like a network cable goes bad, we can switch to a backup. Every row has a backup. We also use that redundancy for other purposes, like connecting a computer from row to row directly to be able to use services like reformatting a Mac using their software. A collapsed backbone is a single central connection point of multiple subnetworks. Typically your highest layer is your router or switch with multi-processes, and then again your central router failure is a risk in this situation. If that one goes down, again your whole network kind of goes down. It's like saying your main switch is connected to your printer. So if let's say the only printer in your building, your enterprise, if that switch goes down, now nobody has that. Also, if your DHCP server is on that main server or on main switch, and that switch goes down, again, you're not going to have any network connectivity because no one's receiving the logical IP addressing. But some of the advantages are you can interconnect different subnetwork types, and you have a central management network where what I mean by that is by having a central management system, it's kind of like ours, where anyone, I'm going to use logging in as an example, but all of our users and passwords are not local on each computer. It's actually on the server. So when you type in your login credentials, your username and password, and you hit enter, it goes to the server to authenticate you as a user. It's the server that says, yes, go ahead, and allows the computer to log in. That's why if our server is down, you can't log into a computer that you've never logged into before, because it says that there's no login server available, which makes sense, because it's saying you're not somebody that's here. I can't connect to the server to authenticate, so you're out of luck. Now one of the things that Microsoft has built in, that if you've logged into that station before and the server goes down, you're able to log into that computer because there's a local profile that's been approved before, so it allows you to log in as that user. Now when the next time the server comes up, let's say that we disable that user account will be disabled as well on that local station. Okay? Switching is just a logical network topology component. There's different types of switching. The three methods of switching is circuit switching, packet switching, and multi-protocol label switching. Circuit switching is when one computer actually creates a circuit to the other computer, and they're able to communicate back and forth. It opens up a channel. That channel is used just to connect there. The session layer is opening, closing it, it's done. It initiates it, and it terminates it as well. On a packet switching, the packet switching is a little bit more complicated because what it does is it takes all your data and puts it into the packets, and the data packets can take different routes to get to that final destination. So when it gets to the final destination, it gets reorganized by sequencing, putting in the right sequence order, and then the computer is able to read it. Kind of similar to, I guess, if you think about how you get your hair cut. You go in to the place to get a haircut. You don't really have to sit in a certain order or anything. You just come in and sit down, but yet it's a first come first serve type deal, and they put you in the right sequence to read the data or get your haircut, and for that example. Packet switching is the most popular. You also have the ability to transmit data. There's some ways to connect to protect, your communication, and some of that is using CSMACD. Okay, now here's two different types. CSMA, that's carrier sense. Multiple access. That's what that stands for. So carrier sense, it's looking at your network for that has a multiple access. So what it's doing is it's going to look to the cable and see, is there anybody already using that? Back when I was a kid, we had party lines. You picked up the phone, and sometimes you couldn't use your phone because somebody else in your town was using that same line, so you couldn't make a phone call. I remember a year when my mom was trying to make a phone call, and somebody on our party line, because you have I don't know how many, 5 houses or whatever on the same line, fell asleep or something, or didn't put the receiver down correctly on the phone so it didn't hang up. So she had to whistle, and she was just blowing, and she's like, hello, because we couldn't make phone calls for that whole night until that person, which actually was the next morning, I think, when they finally realized that their phone was off the hook. But there's two types here: the CSMA CD, which is collision detection. And what collision detection means, if I can spell, collision detection means that when let's say two computers, what they do is they check the line. The line seems like it's like no one else is using it, so it sends data out. They both send data out at the same time. Well, because they both send data out, there's a collision, and the data is lost. Okay. Well, in a collision CSMACD, in a collision detection, your computer says, "All right, there's been a crash, there's been a collision. So what we're going to do is we're going to wait a certain amount of time. That changes for each time, and then it's going to test the wire again, and it's going to resend that information out. That's collision detection. You also have a collision avoidance. Okay, and avoidance, what it does is check. It's constantly checking to see if there's any data on the line. So it checks to see if there's data on the line. If there's not, it sends like fake data out to make sure that it is fine before it sends the real data out. Kind of like a high overhead. You know, it's using your resources, and that's collision avoidance. So here, you know, in Figure 512, you'll see how your computers are actually checking to see if the data is if it has detected a collision or not using the CMSA-CD method. I've also posted up all the notes from the teacher's handbook and stuff. Some things that I would recommend that you look at is the all the cabling lengths, what the speeds are of those. It's a lot of rote learning stuff that you really should know for when you're that's Fit Table 5.1 that has all the different standards on it. And I also encourage you to not only take a look at the PowerPoint on anything that I didn't cover, but also to refresh your mind of things that I've gone over and look at the teacher notes. I've posted all that up to the web. The other thing that you've probably heard in class is power over Ethernet, and that's usually a capital P, a small o, E. Power over Ethernet. That's where it's getting power from your switch. That has the ability to provide power over Ethernet. So electricity is actually going through one of your pair of wires in your Cat5 cable. The benefits of this is like our wireless routers, I believe, in the building. If you look, you'll see that there's only a Cat5 cable going to our wireless router. It's not doing the. There's no AC that's going to it. This requires Cat5 or better. Allows you to connect. You can see in Figure 518 and 519 some devices that's used for power over Ethernet. Other than that, make sure again, watch the teacher notes, watch the look at the PowerPoint, ask questions when we have time, question and answers, and good luck.